Alrighty. Happy Thursday. That's right. I was gonna pull up the book here. Doing file I/O stuff. It's a little bit obnoxious. It's not the end of the world, but it's a little bit of boilerplate typing we're going to get into here from chapter 9. So I'll reference that for a quick example. Um, and then we'll pretty much just copy paste that little bit of boilerplate code every time we do it. It should be a lot of fun. I'm going to go over the solution to the Powerball project. I'll show you how I would go about solving it, and I'll show you how I would go about solving it in a way that's easily testable. And at least several of you here ran into issues with testing because of the way you designed your code. And apologies, that was kind of on purpose, right? I didn't give you a lot of, hey, you should do it this way to make testing easy, right? It's kind of good to run into that once, be like, oh, if my one method does everything here, how do I test it, right? And kind of puzzle through and think through some of that. So we'll look at when we design solutions. That's one of the advantages of good object-oriented programming. If we have classes that do things, we can test those classes, right? Rather than here's just one giant function, one giant method we have to test, and it does way too much, right? We want to do small things at a time, right? In general, you want your methods to fit on your screen, right? If you have to scroll up and down to see what's happening in the method, it might be too long. Again, that's just one way of going about it here, but it's okay, right? We can figure that out as we go. There's some cheesy shortcuts you can do for testing, which I don't recommend, but depending on the road you went down, you might have had to do that and made some attributes public and other sorts of things. It's not the end of the world, right? As long as you got it tested, I'm happy. We'll look at better ways as we go, and then we'll talk about the next project tonight, project 2, our file IO based project. We'll be looking at how to do file input and output, and then we'll look at some of the quick shortcuts we get in Java land, which are really nice here that make doing this a little bit easier. And that should be fun. Um, and then next week, our advanced object-oriented programming, we get into more of those fun details. We look at interfaces, abstraction, inheritance, all the other fun things we get to do, and other cool tricks we get because we can take advantage of those. And then I've never fixed my typo. I really meant to do that. Should I? I'll just fix that real quick because it's going to drive me crazy otherwise here. Um, we got to change that project number. So every time I look at it, I'm just going to feel bad. All right, so this is 3, not 4. All right, there we go. And then back to canvas. Let's see if I can change that one here. And replace. All right. Oh, it has to render it now. It's slow to render. There it goes. All right, and then we'll get to graphical user interface applications. This is a lot of fun. There's a lot of cool things we can do. We'll start with something relatively basic, not too advanced. We'll talk about more advanced things. You won't have to do it right away. We'll get to project 3, and then coming up on the midterm, I'll give you a sample midterm here, similar format to what you'll have, similar questions. They'll just be on a same topic, different words, essentially. And this is just a quick check-in for you. It's open book, open notes, open internet, not open neighbor. It's honestly, it's meant to be doable. Easy might be the wrong term there, but it should be easy for you if you've been keeping up with the class. If it's not easy for you, we got to have a conversation, right? That's your check in here with that here. Um, I probably will set a time limit on it here, just so you don't take all week on it. Um, but 4 hours should be plenty of time here to get something like that done that you ideally could sit and take in 2 hours and 45 minutes if I wanted to watch you. But that sounds terribly dull. So I plan on not coming to campus unless you'd like me to sit here and watch you take the test. I'm happy to do that if you'd like. I can do other things on my computer while you take a test, but no one yet has taken me up on that offer. So if you'd like to, let me know. But if not, I'll plan not to be here on the 16th. You can take it anytime you want in that 4 hour block of time that you like taking tests. So if you like taking tests at 9 in the morning because you're awake, then great. Start it at 9 in the morning, take your 4 hours sometime before the 23rd at 6 p.m. As long as you get it in, I'm happy. Does that make sense? So we'll do a little bit of review on the 9th. And then sprint through a lot of advanced stuff, just kind of dipping in our toes a little bit. And then we're going to narrow in on databases. Database programming is fantastic because I can say with a fair degree of confidence, literally every piece of information in the world is in a database somewhere. Probably pretty confident saying that, right? If somebody knows something, it's probably in a database somewhere. We've recorded it. aside from the little bits of like history stuff. Uh, but in general, all human knowledge is in a database somewhere. So if we can interact with it in code, we have way more tools at our disposal to do cool things. We can interact with all sorts of applications. Businesses run on databases here. This is how things work. So that's a lot of fun. And then we'll finish out databases, more advanced things here. Project 4 will be a database-based project. And then we get into multi-threading and networking. That'll be our final project. Will be based on this concept. Will be a network application that uses multi-threading here. Um, Ideally, we don't all do the same thing because that would be terribly dull for presentation. So each group here will pitch, hey, I want to do this sort of multi-threaded networked application here. I like games. Sorry, your sugar's a little high. Um, Silly little games are fun. You don't have to do games if you don't want. So the demo we're going to do is like a little chat application here. I can run a chat server. People can join the chat server just as a demo for multi-threaded networked applications. And we'll look at some other fun things as well. Should have lots of fun time getting in here. We'll look at some other multi-threading examples that don't rely on networking. Java does some cool stuff with that. And having your threads managed for you is really nice. If anyone's taken the operating systems course before, you'll have experienced multi-threading nightmare. So it's relatively well managed in the Java for us. We don't have to worry too much about too many of the fine details. That'll be fun. And then the network side of things, building out networked applications is really cool. So other people can connect in and really join that world wide web. Is pretty cool. I know Thanksgiving break, and then 12.4. I have no plans to talk about anything. You'll have the entire time to work with your final project group here, which they all should be able to show up, right? If you've got a group member who's not contributing and not showing up, fire them and then they fail the class, right? But please don't do it as a surprise to them. That makes lots of paperwork for me. Like you need to be telling them, hey, you're not contributing. If you don't contribute to these things you've been assigned that you agreed to do, you're getting kicked out of the group. Like they need to have some advanced warning, right? And then you just fail the class because that is worth 40% of your score. Mathematically, you can't pass the class without the final project, and you can't do it by yourself, right? Because we're doing this medium-sized Java program as a team here. Uh, you might be able to do a medium-sized one by yourself, but you have to do it in a team, right? We don't want solo people here. Learn to work with the team. It's good practice here, I promise. Um, and then our final exam slot here. Ideally, you're done by the 4th, and then you can worry about your other final exams and have to cram and memorize stuff for people who think you need to memorize things to show that you learned something. And all you've got to do is show up that night and present. It should be a lot of fun. Your team will show what your application is. Ideally, you bring your computers. Someone plugs in here, runs the demo, and then someone else will join your networked application from their computer and show like, hey, we can communicate here. If you're all on the same Wi-Fi network, it works well. If you're not all on the same Wi-Fi network, that gets to be a small nightmare. But it should work well. We'll test it out here. It should be okay. Um, and if we need to, we can like hop on my hotspot phone network here, and that takes care of most issues with networking here. Can be a little bit weird, but should work pretty well. So we got some time, a couple weeks to work through any sort of kinks we run into in the network here as we go. So that, believe it or not, we're looking at like the second half of the semester already here. I know it's only, was this week 4? But with the midterm, with the final project week, we're getting close to halfway through our content. So it should be a lot of fun. All on the same page? Okay, cool. So let's fire up IntelliJ here and look at the Powerball project. Go back to assignments. I gotta make sure I remember what I wrote down here. Quizzes. I didn't. Yeah, okay. So we'll do the chapter 9. Hopefully you're keeping up on the quizzes. I get lots of notifications from Canvas. Don't forget 7 and 8 due tonight. Yeah, 7 and 8. Yeah, because we covered arrays and classes last week here. A little shorter, so I had to run. But yeah, then we'll do 9 tonight here, and then so 10 and 11 the week after. And I don't usually open them early. Do anyone want them open early? I can open them all early, I guess, but okay, no one's asking for more work ahead of time. Don't usually get that, but I'll open this one up here. We'll set the due date for next week for this one. Um, there we go. And ideally, they're mostly free points. Right? Hopefully, that's the experience you're having with these here. That if you're reading the book, you're getting the points for these because they're the publisher quiz test banks here, right? So 3 points for reading the book. If you have questions about the questions, let me know. I think one of them was a little bit weird, the way they worded it here. We had to puzzle through it, but it was okay. All right. So our Powerball project. We start a new project. This is project 1, Powerball simulator, Java, sample code. Don't need a Git repository because it's already in my public Git repository. And you would have created this in your private repository, right? So that only you have access, I have access, and the grader has access. But again, I'm doing the demo here just to make life easy. I'll put it in that repository. So when we think about solving problems, right, when we want to take an object-oriented approach, which you didn't have to for this one, that's okay if you didn't, right? We hadn't got to classes yet, but you've done classes before in C++ or Python or something. You should have known they existed. Um, anything that's a noun could be a class, right? The things that it does, its verbs, tend to be its public methods, the ways that you interact with it. And then all of the things about all of its attributes tend to just be its attributes, right? Its class level attributes here. So I'm going to leave main for now. We'll come back to main here, and we want to think about the classes we want to have here. We need probably at least one, right? At least a Powerball ticket class that represents an instance of a Powerball ticket, right? Its attributes would be the numbers that it has, the 5 white numbers and the 1 red number, right? Things that you can do with the ticket, and I think I talked about this a little bit here, is you could probably compare yourself to another ticket that you might call the winning ticket and know how much you won. That's, again, doesn't have to happen at the Powerball ticket level, but it seems to make sense that one ticket can compare itself to another ticket and tell you this is how much money I would have won if that was a actual winning ticket, right? And then other things you might want to do, you probably want to be able to get the numbers out, right? So you can display it somehow or represent it as a string here for people who like to put stuff in our console-based applications. It's about all we've done so far. That's okay. Console-based applications are fine, right? And then maybe we'd want to have one for the actual simulator itself that lets you have the options like, oh, hey, do you want to pick your own numbers? Okay, what numbers did you pick? Or did you want to buy some X number of random tickets here? And you just tell me how many random tickets here. And then the simulator could track how much you won, how much you lost, and how much you um, win, lost. That was it, right? Oh, total spend, total won, and total lost. That's right. You calculate your total lost based on your total spend and the total won. Sorry. Probably don't actually need to keep that as an attribute because we can just calculate that, right? It's your spend plus your winnings, right? So again, we could. So I think that's probably a fine approach to have two classes for the Powerball ticket and then the Powerball simulator. Just my approach. It's okay. You don't have to do it this way here, but you'll see it's going to make testing very easily. Make testing it easy. Sorry, not easily. I need a little more coffee. We homeschool our kids, but my 16-year-old decided she wanted to go take electives at the high school down the street. And for some reason, high school starts at 7:15 in the morning, which is really early. I know you all went to high school probably recently here and you experienced that, but it's been a lot of years for me, and I don't like mornings because I'm usually up till like 3 in the morning. So getting up to take her to school this week has been miserable, and I'm going to be cranky for a while until I get used to that schedule. Um, so I even took a nap after too. I was like dropped her off, picked her up, and took a nap. And I'm still tired, so I got my coffee. I'll go get more coffee in a little bit here. We should have some fun. And let's see, why was my pump beeping at me? I think my sugar was going low. Oh, okay, I'm stable now. So should be good. So in the testing bit, at least 4 winnings we had to do. We'll show you we can test other things as well. And, you know, any code that's worth writing is worth testing because you want to know that you did it right. If you don't care if you did it right, then why are you even writing the code in the first place, right? You just have garbage. If you don't know that it's correct, you can assume it's garbage, right? Unless you can prove you did it right, you probably made typos somewhere, right? I make typos all the time. Obviously, I do it on purpose so you can see that I make typos, and that's the kind of example you'll run into debugging your own code, right? No, it just happens. That's normal. It's okay. And we'll go through and fix it. So let's start with the Powerball ticket class. I'm going to go add a new Java class. We'll call this one Powerball ticket. Again, we should start our classes with uppercase letters in Java land here. That's our convention. We get a new file with the name of the class here. And we want this to be a public class so I can go and test it here. You could technically stick a private class in the main class here, and then it gets really hard to test, basically impossible, because it doesn't exist outside of the main class, right? It's private. So you want it to be public, right? And then the things about it here, we want to go and import java.util.ArrayList here, because I want to use an array list to hold my numbers. You could use an array. I like array lists. I think they're a little easier, a little more flexible for me to use here. If you use an array, that's fine too, but I'll use an array list. So I'm going to have a private array list of type integer here for my white numbers here, and I'll have a private int for the red number. Right. So those are the attributes. Those are the things about my Powerball ticket. Right. We know that. All right. Why is it still beeping? My phone didn't tell me why it was beeping. It doesn't even tell me why it's beeping. That's lots of fun. I might need to go get a Coke in a minute, but we'll see. All right. So attributes of Powerball ticket. Great. Now, how are we going to go and set these things here? We probably don't want to give just public access to someone to go and set the white numbers, because one of the jobs of our class is to maintain the integrity of the class. And the rule with a Powerball ticket is you can't have repeated white numbers, and you can only have the numbers 1 to 69. So I can't just give public access, right? That would be bad. So we need a way to go and set those numbers correctly. And once they're set on your ticket, should you be able to change them? No, no, because if you could change your lottery ticket numbers, yeah, right, we can all see why that's bad. So we would need a way to set them once and not change them. That sounds like that has to be in the constructor, right? If we're going to allow them to set the numbers and not change them, we don't have a public set method, so we have to take them in the constructor as an argument. Right? So we're going to write a constructor method. Remember, constructor methods don't have a return type here. They're special. So it's just public Powerball ticket here. And then we need some values. So I'll take a array list. Here, actually, I can just go generate that. We'll save myself some time here. We'll go generate. I want a constructor, and I want both my attributes. So shift click. I want to take both. Give me white numbers. Give me red numbers. Now, again, this is bad. We haven't validated yet. So we can't just take the generated code, we have to do something a little smarter, right? So first, let's make sure the white numbers are valid here. Okay, so to be valid, all of them have to be within 1 to 69, and we can't have any repeats, right? So we could do that right in the constructor, or we could go write a helper function that has a name that's telling us what it's doing. Right? I'm a big fan of putting names to our code. It's one of the most important reasons we have functions and methods is you can put a name to it. Yeah, it makes code reusable. Yeah, that's a good benefit too. But it's nice that it puts a name to it here. So we're going to go and validate here. So we're going to validate white numbers here, given the white numbers. Before we go and do that here, and it's going to tell me, oh, I don't have a method here. Do you want to create it? Yeah, let's create it. I like that, right? Private void validate white numbers given an array list of integers. Like, yeah, please write some code for me. Fantastic, right? To validate, then every number has to match, right? So for, we can say int number in, I'm sorry, colon my white numbers, the little enhanced for loop here. Go through and pick the numbers. It's telling me it's empty. So I'm so used to like looking at these warnings here, and I forget IntelliJ is faster than I am here. Yes, of course it's empty. Okay. So if my number is less than 1, or my number is greater than 69, we've done a bad thing here, and I want to just throw an exception. Throw a new invalid argument exception. Valid argument. Oh, is it argument? So what is it? What is this one? Illegal argument exception. Number can't be less than 1 or greater than 69. Right? We'll be very forceful here because you can't create an instance of the class with bad numbers, because this class should not allow itself to be in a bad state. This is the forceful way of doing something. I can't just like print out a message here because people are going to ignore it, right? Nothing makes them do anything about it. So we just raise an exception, throw a new exception here, okay? That's our first check. Then we need to see if we have any duplicates. So first, are they all good? 1 to 69. Now, do I have any duplicates here? So we can go through, right? Because we have an array list, we have some cool extra features. Another reason I like array lists here. So I can say, I don't know, we'll say for int number Actually, let's just do it in the same loop here, right? Why not? So we're already looping through. We'll first just check for this one here, and then I can say, hey, if my white numbers dot, what is it here? There's a way to count it here. Doesn't there give me a count? Size, remove, index, add, equals. Oh goodness. Is there not a count right away? I have it contains, but it's going to contain. I really thought there was a count here. Is there not? Count of in array list. Let's see if there's someone here. So you can Google it here. Count of item occurrences in array list. How to count here. Does it give me anything good? That compiled search is so slow. Collections.frequency can count occurrences of an element in a list here. Okay, so collections.frequency here. Right, we can use this one. Sure, why not? And this is what we searched for here. So, and I'm going to cite my source because I didn't remember what it was here. So we did Bing Java count items here. So we use collections. We need to go import java.util.collections, collections here, right? So if the collections dot occurrence, oh, I'm typing it wrong now already. Collections dot frequency, sorry, frequency in the white numbers, right? Of what object here? Of the number, right? And then frequency is going to give me an integer value, right? So if that's greater than 1, you can throw a new exception. Here, I'll just copy this one here. Number can't be repeated. Now, it might be nice if I actually told them what the number was. I don't really care at this point, right? That's just icing on the cake here. It's okay. This should get the job done, right? And again, great. I didn't remember how to do that. We Googled it. Right? I got paid a lot of money as a developer to Google things all the time. But we're going to cite our source because this is academia. Is that fair? And again, it was a small piece here. I didn't ask for the entire solution, right? I'm hoping I'm demonstrating good habits. Like this is what you would do, right? That's what you all did when you came up with something you didn't know. You cited your source when you Googled it or Binged it. They give me free coffee, so I use Bing all the time. And Google has enough information about me anyway, so might as well spread that out. Right. So if we made it this far, the numbers should be valid, right? We didn't throw a new exception, or if we didn't throw an exception, we can continue on and assign my white numbers here, right? You okay with that so far? And then the red number, again, we want to validate that one. Again, that's just 1 to 26. If you want to make a validate red number function, you could, or we could just check real quick here, right? Hey, if my red number is less than 1 or red number is greater than 26, and I'll just paste in here, number can't be, or what, red number, Powerball number, whatever you want to call it here, greater than 26. Oh, I missed my quote here. There we go. We'll raise an exception there, and we can continue on. So generally, you want those at the top here. Just it's kind of a better form to do your validations and raising exceptions first, and then continue doing with your code here. So we'll put our checks up there. Is that okay? All right. So we made sure if you pick the numbers, they should be good, right? So now we've picked the numbers. Now we need a way to get the numbers back out here, right? So we probably want to go and add some gets here. So we'll go and generate some gets for white numbers and red numbers here, right? Usually you want these below the constructor. Some people are particular about it. Some people aren't so particular about it here. With public methods near at the top and then the private ones below that. So as you're scrolling, you see constructor, private methods, or public methods. And then if you want and you're curious what all the private things are, you can keep on going. Just to make life easier and a little bit more readable, here as we go. It's warning me, oh, it could be final. We haven't really got to what that keyword is yet. It's like you said it once and you can't change it. It makes it unchangeable in the code. Great, it's a fine suggestion here. We like that here. We'll call it final. No worries here with that. And now it's warning me, we never used it. That's fine. So now I can make a ticket with some numbers. What about making a random number ticket, right? Now, we could do that outside of Powerball ticket, or we could make another constructor, an overloaded constructor that will generate a random ticket. And I think that probably makes sense for a Powerball ticket class, right? You can make an instance with fixed numbers, or you can make an instance with random numbers. Right? Does that sound reasonable to do? All right. Again, either way, it's okay. I think it'll be, testing with random numbers is a big pain here. You probably don't want to go down that route, right? And I'll show you, you could seed it and you could pick out some sequences and things like that, but I'll make it be a big headache here. So we're just going to generate another constructor that takes no arguments here. Select none. There we go. No argument constructor. Well, now it needs to go and set the value. So, uh-oh. It might not have been initialized. It's telling me right away you have a constructor that didn't set the value. So yeah, let's go set them here. So let's go import random, import java.util.random here. And my random equals new random. Create a new instance of random here. So we can go and get some random numbers. So I need to go get 5 numbers 1 to 69 with no repeats here, right? And to do that, again, I like the array list because we had that contains method. Right? I can see if that number is already contained in the array list, just pick another one. So I'm going to just pick the first random number here. So we're going to say while um, we need to create the instance first here, right? So let's say my white numbers equals a new array list here. Um, it already knows it's integer. You don't have to repeat integer when we're using array list. Sorry, I kind of skipped over some of this last week here, but hopefully you picked up on that. Um, it knows it's a type of integer here, so it's just saving a little bit of typing here. Right, and now while my white numbers dot size is less than 5, let's go add some numbers to it. So we're going to take my white numbers and we're going to add a new random, I'm sorry, not new random, add random dot next int. And I want 1 to 69, but this is exclusive of that number, right? So the upper bound needs to be 70, right? Or I could do 0 to 69 plus 1, or 1 to 70, right? Whatever way I want to do that. Here should be okay here. Had a couple options. But can't just add the numbers, right? We said we needed to make sure it wasn't in there first. So we'll have a int for random number is our random int 1 to 70, right? And then if my white numbers dot contains the random number, right? Really, I want if it does not contain the random number, then I can go add that random number, right? If it does contain it, not true is false. Nothing happens here. We just go back to the while loop. Hey, is my size less than 5? We just keep on going, right? A lot of ways to go about it here. It's okay. This is just the first thing that came to my mind, right? So this should add 5 numbers with no repeats, 1 to 69, generated randomly. It should. We'll go find out if it actually does here, right? We can test it and see in a little bit here. Right, and then it needs to pick a red number, right? My red number then equals random.nextInt from 1 to 26, but it needs 27 because it's not inclusive of the upper bound here, right? You okay with that? Now, if we wanted to make this even prettier, right, we know these like magic numbers here, bad form, we should probably have some constant values somewhere, some values, right? Again, that's just icing on the cake. Not super important here, but I just have 70 and I have 27, and they don't really mean a whole lot. So we might as well add some, right? So we want to have a private, now we would probably declare this one as static. We haven't really got to that yet, so don't worry about it here. We'll just say it's a final int, and we'll go all uppercase, max white number here. We'll say is 69. Now, assigning things when you declare them technically works. It's a little bit ugly, and ideally, if it was static, it would make a whole lot more sense for the constructor not to do it. Don't worry too much about it here, but that's okay. So we'll say this is my max weight number plus 1. Sure, is that okay? And then a private final int max red number is 26 here. We'll do the same thing with my max red number plus 1 here. So at least I have something nice here. The 5, maybe we could even do one for that, right? Like number of white values or something if we wanted. I don't know. Private final int, I don't know, number of white numbers. This sounds a little bit ugly, but that's okay, right? It's not the end of the world. You can come up with good variable names here. I'll just make fun of you if they're terrible. That look a little bit better. So hopefully we're not using quite as many magic numbers. And then in my validation here, right, I can look for my max red number. max red number. This makes my loop look a little bit nicer here. Oh, that was, yeah, for red number, and then my validate here was my max white number. White number. And just trying to reduce some of those magic numbers. I think keeping one is probably fine. That one seems pretty obvious, but if you wanted to have a minimum number, sure. You could have come up with some crazy lottery that doesn't start with the number one. I don't know, but that's probably okay. Let's see, it's to be converted to local. It's okay. I'm fine with that. We only use it once, so it's saying, hey, you could just make it in here. Okay, so now we can make a random Powerball ticket. We can make a Powerball ticket with the numbers we picked. The class seems to be doing its job so far, right? It's going to validate. I didn't validate the random one. You know, if we wanted to be lazy, I guess we could go pick 5 random numbers, then call our other constructor and make sure we didn't throw an exception. But that sounds really awful. And ideally, you don't want exceptions to happen because they're slow. So if we could do something with logic that doesn't use the exceptions, we're going to run faster because exceptions slow down the program execution here. Um, and this is probably good. So the other thing we need to do now is figure out how do we know how much money we won, right? So let's go through and we'll have a get winnings, right? So we can get our numbers out here. We'll have a public int for get winnings here. Given another Powerball ticket, I'm going to call the winning ticket, right? So if you give me another ticket, I can compare myself with the winning ticket, right? So I know what my numbers are, and the winning ticket, I can get their numbers. We're going to go compare, right? So we need a way to get how many times or how many white matches we had, right? Because you can have 5 white matches, 4 white matches, 3 white matches, 2 white matches, 1 white match, and then if the red ball matches or not, right? So we can go count that. So I need an int for white matches here is going to be, I don't know, I just want to make another helper function for it. It could be in here, but it's a loop. I don't know. We started at 0. We can just do a loop here. And maybe if this gets too big, we'll move it out. This is going to get big because I'm going to have a bunch of ifs. So I might move it out eventually, but we don't have to start with that, I guess. So we'll say for int number in my white numbers, right? Okay, so for every number in my white numbers here, if the winning ticket dot get white numbers dot contains the number, take my white matches plus plus. And just do that for each of my numbers. That's it. Now I know how many white matches I have. You know, 4 lines of code we can move to helper function. It's probably okay right here. That's not too big of a deal. And then I'm going to have a Boolean for red matches here, which is my red number equals the winning ticket dot get red number. Right? Is it just true or false? Because I'm going to use this in my ifs. If I, had 5 white matches and the red match, I get my jackpot. If I had four white matches and the red match, I get this much money. Right? Going on down that chain of winning results here. So I'm going to use whether or not they matched, and I don't want to have to type this every time. I saved a little bit of time here, right? Not too big of a deal. So now I can compare them. Now, the funny thing you can do in Java land, because winning ticket is an instance of Powerball ticket, you don't have to use a public function here. I can say winning ticket dot white numbers directly here and access a private attribute, which sounds like we shouldn't be able to do that, right? You shouldn't be able to access another class's private attributes, but it's not another class. So within the Powerball ticket class, if you have another instance of that class, you can access its private attributes because you're still within the same class. Gets to be a little bit funny here, and generally I just use the public methods here, but if you didn't want to give someone a public method for get white numbers, I don't know why you wouldn't, you could still access those private attributes here. So you can do fun things like that. And like instead of get red number, I could just get the red number directly, access the red number attribute directly here, which is fine. One way or the other is okay, not too big of a deal. And now we'll just go down the chain. So let's check for jackpot first, right? Here's your highest winnings, and then we'll work our way down the chain. So if my white matches is 5 and my red matches, I can return. Now we don't actually, the jackpot changes here. So I think a couple people asked me what number should I use. I just said make one up. It doesn't matter because you're not going to win anyway, right? Well, let's just go with, how about max integer? Max integer might be bad because it could like overflow our integer counting. So if we just go with like, I don't know, 2 billion, we're probably okay, right? So let's go with 2 billion. 1, 2, 3, 2, 3, 1, 2, 3, right? 2 billion. And again, this might be nicer to have as an attribute here, right? So why don't we have a private final int jackpot is 2 billion, and then I can return the jackpot. Now, you might want to do that with all the other prizes too, Sure. Anytime you have the number in there, it's nice to put some context to it. But like prize for 5 white matches, yeah, it's not the end of the world. We can do that, right? So if we didn't have this, then right, else if white matches is 5, we can return. Oh, we're just gonna make another value for it. Why not? So we'll have a private final int 5 white matches prize. I don't know. Sure, that was $1,000,000, right? 1, 2, 3. It's 4, 5, 6 zeros. I shouldn't remember that, but I like doing Powerball a lot because I enjoy bashing on the lottery. And then if you do get to play Powerball, I get to complain about how awful the lottery is, and no one should play and waste their money on it. So, and then you've done something sort of practical, right? Right, and then else if my white matches is 4 and the red matches, right? What's my prize here? This one I don't remember. Was it 50 grand or something like that? Powerball prizes, Powerball prize chart, Powerball.net. Who uses a net domain anymore? That's the craziest thing. Um, 50,000. Okay, cool. 50K. I think I had that right. So return, let's go add another value. Why not? So this is private final int 4 white and red. Prize was 50K. Right, and then else if, now we can start doing a little bit more interesting logic here because you have 2 different ways of winning the $100, right? 4 white or 3 white in the Powerball, right? You can have them in separate ifs, you can have them in the same if. However you want to do it here, right? So if my white matches is 3 and my Powerball, I'm sorry, if white matches was 4, right? Or, and then white matches is 3 and red matches. Now, just be careful with your order of operations here, because remember, ands happen before the ors, but if you don't remember that, just put the parentheses in. It's not hurting anything here, right? Because this one is true or this one is true. And I know the red match can't be true because I got past this one here. Because I'm chaining these all together, I don't need to say, and red match was false, right? Um, and you did notice I don't have to say red matches equals true, right? If it's already a Boolean, you don't need to say is does true equal true. Just if it's true. Right? You just use the value of it itself directly here. So if that one was true, then I have my private final int, and this is 4 white or 3 white and red. Oh my goodness, prize. That just looks stupid here, but sure, why not? Let's go with it. Um, you just commit, right? Return that one here, and then else if my white matches is 3 or white matches is 2 and the red matches, that one I think was $7. Yeah, $7. And I don't want to type this whole thing out here, so I'm just going to copy paste, and this is then 3 white or 2 white and red 7. And then we just have a private final int for, this is red match, is $4 here. Okay, so then this one was the 3, return 3 white, and then remember, it doesn't matter if you had a white matching or not for this last one here. If you had the Powerball matched, you got $4, regardless if it was 1 white or 0 white, right? So I just care now did the red match here. So if red, else if red matches here, we can return the red match here. Otherwise, my last trailing else then, right, I can return 0. Return 0. You won nothing. Goodness gracious. And I don't think I need to put, parentheses here. And that's why it's yelling at me. I don't think I need a hard-coded no prize. I think 0 is okay, right? Should we call this like you lose? Would that be funny? Why not? Okay, let's go with it. Because we can come up with any variable names we want here. Private final int you lose is 0, right? That's entertaining. Why not? And now it's consistent at least, right? We're returning a final value every single time. Again, these probably should be static. Don't worry about that until we talk about that next week. Okay? That makes sense so far? And again, it's a little bit long, right? It'd be a couple lines shorter if we could move out those 4, right? Why not? So I'm going to right click and I'm going to say I want to refactor. I want to extract method. And we're going to use our tools, right? I don't like doing more work than I have to here. And this tool's fantastic here. So get white matches. Cool. Got it. I like it. So I'm just going to go back here, get white matches here. Um, why do I pass white matches? No, that's weird. All right, I don't know what it did over here. Let's go see what that function did for us. Where did they even put it here? Where did they put my function? Get white matches. Where did it go? Oh, it's right there. I scrolled past it here. The winning ticket. I don't need an int for white matches. No, that was dumb. All right, so I didn't do a very good job of it. That's okay. Int white matches. Oh, I didn't highlight the white matches above them. So I didn't cover enough of it. Maths matches, matches. Okay, 0. Count it up. Return the white matches. So now my white matches equals get white matches. Cool. Red number. Did we match here? So this, if I wasn't zoomed in, would fit all on one screen here, right? And I feel pretty good. Like, hey, my method fits on one screen. Sure. Again, it's just a rule of thumb. There's no rule about it. Yeah.
Could you add contrasting directly next to the subset you can turn it and turn below so kind of
Inlines.
yeah.
You could. I think that looks awful. I know some people really like it. Inlining. I like my curly braces, and I would argue you should always use curly braces, even if it's a single line here. Because did I tell you the story about Safari years ago? Probably before you guys were born. Okay. There was an SSL vulnerability in the Safari web browser years and years and years ago because their lazy developer didn't use curly braces around an if block. So the SSL security was you were able to get through it here if you knew what you were doing because their developers were lazy and didn't use curly braces. So ever since then, I swore I would just always use curly braces. But yeah, you could totally inline it, and you don't even need the curly braces because they're only single line returns here. I just think it looks ugly, but that's okay, right? It's just a style preference. Yeah, and then that would also save me now, right? I get half the lines of code essentially, because it's all already in line here. Uh, yeah, totally an option here. All right, but so we did it, but does it work? That's the important question, right? Because we wrote a bunch of code. Does our code work? Well, now we need to test each one of these prize levels, right? Ideally, we can get to 100% code coverage, right? All my lines of code should run when I'm testing to make sure it works here. Now, the weird thing about that metric is this if block is a single line of code. So it runs whether or not I test the 4 white matches or the 3 white matches and a red match. I probably should test them both here because I care that it correctly catches them here because I copy paste things all the time, and if you forget to change numbers places, bad stuff will happen. So it's probably worth testing each one of those individual cases here. But your code coverage metric isn't going to change because it's all in the same line already. So again, metrics are only so valuable here. So and I said, this at least is what we had to test. Can we calculate a jackpot correctly? However you did it. It didn't have to be in a Powerball ticket class. But now I think you can see really quickly, I can just give you 2 Powerball tickets, call get winnings, and test the number like that. I don't have to go through a bunch of hoops. There's no user input attached to my class. Right? Classes should have nothing to do with user input because you don't know where the user input's coming from, right? It could come from the console, it could come from a graphical user interface application, it could come from a mobile application, could come from a web application. We don't care, right? The class shouldn't care where the input comes from. The class's job is to be the class, right? That's why we write this with the separation of concerns, right? It encapsulates all those nice details, it maintains its integrity, it has its attributes, it has its public methods, it's happy. Okay, so let's try it. So let's go right click and go to test. So go up to the class, say go to test. It says you don't have any tests. Yes, I want to make new tests. Yes, that's fine. JUnit 5 is good. I want to test get winnings. We're going to test this a lot here. That's okay. It's red. It's red. I need to go import. Make sure you don't import JUnit 4 because we said we wanted 5. So pick your JUnit 5. Yep. Tell Maven, please go download that thing for me. Usually it works. Every so often you have to kick it. I think I had to kick it last time, but usually it's pretty happy with that. And now we're going to have a bunch of tests, right? So we'll do get winnings, we'll do jackpot, and then we'll do another one. I'm going to copy paste it after I have all the other stuff here. All right. The AAA convention, we're going to arrange our variables. We're going to act. We're going to test the code, call the code we're testing. And we're going to assert, did we get what we expected here? Right. And it's just a convention. You don't have to do it this way, but if everyone does it this way, life is easy for all developers. Right. But not everyone does it this way. It's okay. But I'm fond of this format. So this is the format I show. And it's a pretty popular one here. All right. So what do we need? We need a ticket. We need a winning ticket. We need the expected winnings. and then we'll go call get winnings. That's the code we're testing is get winnings, right? And then we'll assert it matches. Okay, so we'll have a Powerball ticket. Ticket is a new Powerball ticket, and we can give it a bunch of numbers here. So we need a new array list of type integer, given some values. One, two. Shoot, I can't. Hang on. There's an initializer syntax, and I'm just not remembering it right now. So we'll make a uh, array list of type integer for the white numbers equals 1, 2, 3, 4, 5. No, is that not the syntax? Array new int? No. Two new. I don't know. No, I wanted the values. Oh my goodness. Why? We just did this last week. Java create array list with items with values. Arrays as is that really what you have to do? List of why? Arrays as list? Is it really that ugly here? That's awful. Goodness. Okay. Anonymous inner block. That's the one I was thinking of here. Okay. This one here. This is what we want to do here. We'll steal this one here. This is my white numbers. Array list of integer. Given add. Oh my goodness. Sure. 1, 2, 3, 4, and 5. Man, I don't want to have to do that more than once. All right. And hey, we should, I don't know, I had to Google that one here because I don't remember what it was. Let's go cite a source here. Bing. Sure. Is that fair? If I have to search something, you should like get on my case and make sure I cite my source because I should also practice that. But no one's going to remember everything. All right, so we added 1, 2, 3, 4, 5, make our Powerball ticket with the white numbers, and 6, right, for our red ball here, right? And then we need a Powerball ticket for the winning ticket. Powerball ticket. The winning ticket is a new Powerball ticket, given the white numbers and 6 here. Great. Feeling bad already here. So let's go make an int for red ball. Red number is 6. Because I'm going to want to change this later. I don't know. Can you use a variable here? Maybe. Once a semicolon. Semicolon. Right, and then we need the expected winnings. An int for expected winnings is my Powerball ticket dot. Oh, did I make those all private? So if they were public, I could just go access them. Let's just do that, public. Again, these should be static, but we haven't covered that, so don't worry too much about it here. Public. Why am I typing that every time? Public.
Public. You folks. Like instead of automating these parts, there's a way that you can highlight the whole thing.
Yeah, there's like highlight the same word on a couple. I forget what the keyboard shortcut is for that. We can go Google it. Like if you just grab them all and do something. Oh yeah, change access modifier. Nice. That's handy. All right, so then my expected winning Powerball ticket dot jackpot. No, Powerball ticket. Oh, it's because they're not static. Ticket dot jackpot. There we go. If they were static, I could get it from the class. Again, we'll talk about it next week. Sorry, I got a little out of order here. What are our expected winnings? We have an int for actual winnings. Actual winnings is my ticket dot get winnings given the winning ticket here, and then I can assert did they match? Assert equal my expected winnings and my actual winnings. All right, so if I make 2 identical tickets, do they match? Do we get a jackpot here? Right? Let's test it. That's the moment of truth. Is it going to work? It's okay to bet against me. That's fine. Happens all the time. It passed. Life is good. It worked. Right? Cool. Why don't we test the next one? So that was jackpot, right? So I would just copy all this one here. We did the, I don't know, test million or 5 white match. Okay, so that's where red number doesn't match. Sure, I don't know, just change that to 7 or something here. And then this is my 5 white matches prize. Cool. And then we want to test for the 4 white, 4, white and red here. So 4 white match. So this one's a 6, but the red numbers match, right? Oh, I have to change the other ticket now. So this is my white numbers, and I need a winning white numbers here. So winning white numbers. Now we can't give them the same numbers anymore. So we'll use the winning white numbers for the winning ticket here. And then this one, I don't know, we'll just change one of them to a 6 here. So we should have the first 4 should match. We probably want to test the work out of order as well, right? Um, now that I finally have a different order, so let's do that too. We'll do 4, 3, 2, 1. Why not? Again, just want to feel good about it working here. It's not, doesn't do the exact same thing here. It's fine. This is my now 4 white and red prize here. Right, and then we'll go copy paste. I want this one now because I'm going to be changing my values around. So this is 3 white, or 4 white and not red. Just regular 4 white. And how much did that one win? Yeah, 4 white, right? So it should be the 4 white, 4 white here. So just 4 whites, but not the red number here. So if the red number is something different, like a 7, 1, 2, 3, 4, 1, 2, 3, 4, the 6 and the 5 don't match here. That should be good. And then we'll test it again with 3 white and a red. 3 white and red. So 1, 2, 3, 6, 7, right? 1, 2, 3, 4, 5. So, okay, that should be fine. We do want the red to match, so go back to red number. Sure. And this is 4 white or 3 red, right? That was the three white and red prize, so the same prize here. It's been a little while. Let's run a bunch of them here and see. I was going to do them all, but this is fine. Let's make sure they all pass here. There's possibly a typo here too. That happens. All right, they're all passing so far. That's good. That's good. We're almost there. All right, that was 3 white and red. Then we want just 3 white. So 3 white, but not the red number then. Right, so we change that back to like a 7. So it's 3 white here. Great. And then we'll do the 2 white and a red. So it's 2 white and red. And red, so just 1, 2, and then I don't know, make that one 8. I'll go back to matching on the red number here. Red number. And that's the same 2 white and red prize. Great. And then the last one here is 2 white. Oh no, that was it. So that's just the Powerball, right? So one last one here is just red. Is red. So none of these should match then. So we'll go 8, 9, and 10, right? 1, 2, 3, 4, 5. But the red number matches here, and that should be just the red match prize. And then we want one to make sure that you win nothing, right? We should probably test that case here because we wrote the code for it. We'll test that one too. So get winnings, you lose here. So if none of them match here, right, and the red numbers don't match, so we should get the you lose prize, right? Let's go run our tests. A lot of copy pasting here, but it's a way that I can set the numbers and test, am I getting the result I expect, right? Because we wrote the code to check the winning, so I need to make sure that it's doing what it's supposed to do. And it looks like they all pass. I feel good about it, right? Make sense so far? All right, awesome. That's a Powerball ticket, so I think it does what it needs to do. Okay with this one? Now we can write the simulator. That one's pretty quick here, right? So we'll go make a new class here for the Powerball simulator. Simulator here. And again, this one has it has a private int for total spent, a private int for total won, and we probably have like a private final. Actually, Powerball ticket probably knows how much it costs, right? We should probably have a value for how much it costs, right? Like a public final int ticket cost or cost per ticket. I don't know, cost per ticket. That's $2, right? Probably makes sense to be part of Powerball ticket, not the simulator. I don't know. You could move this around because you could also do like the double plays and other nonsense ways to spend even more money in the lottery, but that's fine. So the total spent, the total won, and then we need a way to go and set this up. So a public Powerball simulator, Powerball simulator here. We don't need any values here. We just go set those to 0. So total spent is 0, total 1 is 0, right? And then we need a way to pick a ticket here. So we can make a public, I don't know, probably return a string or something, right? Because we want to be able to show something here, and we can return the string results, or we got lots of options here, but this is probably fine here. This is, I don't know, picked ticket or chosen ticket. I don't know. Here's the numbers. I don't know. Play with chosen numbers. How about that? Given an array list type integer for the white numbers and an int for the red number. It says, oh, I need to import array list. Yeah, sure. Let's go import array list. Alt enter. Yes, please. Do it. There it goes. Alt enter. Import array list. Great. So now with the simulator, we're going to try and make a ticket from these numbers here. We probably should try and catch because we know this could raise an exception, right? So we're going to use our try block and say, hey, something bad could happen here with that exception. Let's try it here. And then we can catch an invalid argument exception. Invalid argument, or no, what was it? Illegal argument? Illegal argument exception. We return the exception to string, right? Whatever that string message was, we'll just return it here. We're going to try. So we'll make a ticket then. So Powerball ticket, Powerball ticket is a new Powerball ticket given the white numbers and the red number, right? And then we'll have a Powerball ticket, the winning ticket equals a new Powerball ticket as a random ticket here, and then we'll get the winnings, right? So we'll have an int for winnings is ticket.get winnings, get winnings given the winning ticket here, and then we can return the string, right, that shows all this information here. So if we want to build out a nice looking string here, we might have your numbers, the winning numbers, here's your how much you won, right? That might look kind of nice. So to get Powerball ticket as a string, we probably should add a toString method here. Right? That's just a nice way to go and represent that. So let's go generate a toString. Generate a toString function here, a method here. We want the white numbers and the red number, right? So here's the white numbers, here's the red number. Sure. Don't think, does ArrayList do that? Let's find out. That might work. If not, we have to go through and loop through ArrayList. I don't actually remember right now. But we can return then, or we'll make it, I don't know, a string to return or results is the ticket, toString. So maybe we'll say your numbers, your ticket, and then append in the ticket toString, and then maybe a new line here, right? Add in new line character, and result we can add in. This is ugly doing string concatenation, but it's okay. Don't feel too bad about it here. The winning ticket, right? Is my winning ticket toString, winning ticket toString, and probably a new line as well. And then my result will say you won, and then add in the winnings, and probably a new line. I don't know. That's fine. That's probably enough here, like that, and then we can return the results. Right. Great. If an exception happens, just return that exception, right? We're just returning a string here. That's fine. Oh, we also need then to add to spent, right? Our total spent and total lost, because we're tracking all that here. So my total spent plus equals my ticket dot cost per ticket, and my total won plus equals the winnings. Right? So we're tracking that as we go, right? So that should be for picking numbers, play with chosen numbers. Great. And then a public string, say random tickets for an int for number of tickets. Sure, why not? We basically do the same thing here, but we need to loop through a bunch of tickets, right? So let's try and catch. Actually, we don't even need a try block, right? Because random tickets should not throw an exception here. So we should be okay here. So we'll just go through and do this. We're going to do it a bunch of times. So we don't need white numbers and red numbers here. I only need one winning ticket here, right? The math should be the same regardless of how we're doing it here. So then we'll say, I don't know, for int ticket is 0, ticket is less than my number of tickets, ticket plus plus. And then we'll go make a new ticket here, get our winnings, add it all here. Eventually we can return results. So maybe our string result starts outside of here, string result equals just nothing to start here. And then we can just keep on appending in as we go. So adding in. So maybe I do want some new lines here then, right? Lots of new line. So that's all separated out a little bit. I don't know. It'll probably work out okay. String concatenation in a loop. What's it? Available results. The string builder is the right way to do this. It's much more efficient in memory. It doesn't have to create new strings every time we concatenate, but it's okay. Um, that's probably fine. We get our winnings here, and eventually we can return the result. I think that's it for buying tickets, right? Powerball ticket. Ticket. Oh, it's already used. Oh, shoot. We'll call this one, I don't know, ticket number. Ticket number. Ticket number. We never use number. We could number the tickets in the output if we wanted here, but that's fine. Right, that should work. Right, so now I have a way to go and do these things with the simulator here, and then we probably want a way to get the total spent and total won. Right, so we can go and add those ones here. So let's generate some getters, total spent and total won, and then a public int for get total loss here. We're going to return my total spent plus my total won. I'm sorry, no, my total won minus total won minus the total spent. Right? How much you won minus how much it cost you. It's probably is always going to be negative, right? The more you play, the more you lose, right? But we can generate this value. It doesn't have to exist as an attribute here. It looks like it's one because it's called get here, but my class is abstract. So whoever's using this method doesn't need to know the attribute doesn't exist, right? It just happens, right? And then we have main, right? And then we can go make a Powerball simulator. So Powerball simulator, I don't know, Powerball simulator equals a new Powerball simulator, sure. And we can do our little menu. Do you want to pick numbers? Do you want random numbers? How many random tickets? Or do you want to quit? Right? So we have an int or a string for their choice is, I guess we should print first. Do you want to one buy a ticket with specific numbers? Pick numbers? Sure. Pick numbers. Pick numbers to buy random tickets, random numbers. There's 3 quit. So not the prettiest looking menu here, but it should get the job done here, right? And then we need a way to get some input here. So we use that scanner. Keyboard is a new scanner, given system.in. And yes, we want to go import it. Alt enter. There we go, import scanner. Choice is my keyboard.next line, next line here. And then as long as it's not quit, right? While my choice does not equal 3. Oh, but we shouldn't compare this way, right? Dot equals. Now I don't even care about ignoring case, right? Because it's numeric values, which is nice here. Well, it doesn't equal 3 here. Let's keep on going. So maybe I even set choice above, right, to something that's not 3. I don't know, equals anything other than 3 is fine, right? We'll go pick something here, get a choice, and then if my choice is 1, dot equals 1, 1, we go and have to get some input, get some values, right? Else if choice is 2, equals 2, we'll ask them how many random tickets they want to buy, right? Maybe we'll do that one first. How many random tickets do you want? Right, and then we can get that value, so an int for number of tickets. Tickets is my keyboard integer.parseInt of the keyboard.next line. Right, I typed in a value here, and I'll take my Powerball simulator dot play random tickets given the number of tickets here, and that's going to return a string. So maybe we just print out whatever we get back from that here. Right, and then we can print out the net loss, right? Total won, total loss, total spent here. After that, print out total spent plus my simulator dot get total spent. This is obnoxious here. Maybe we'll turn that into a function. That's fine. We'll do it. Total spent, total won, net loss is get total won, get total loss here. All right, and then sure, I guess we're going to do that every time anyway. So maybe we do that outside the loop, right? Right. regardless of whether or not we bought tickets or not, right? If you pick the numbers, we didn't pick the numbers here. So if you wanted to pick numbers, we got to get some numbers. We need an array list of type integer for white numbers, and equals a new array list of type integer. Great. And then ask them for 5 numbers. Sure, I don't know, while numbers dot size, white numbers dot size does not, or is less than 5, does not equal 5. I don't know, whatever we want to do here. It's out to a white number 1 to 69. Take my white numbers dot add the integer dot parse int of the keyboard dot next line, and we'll do that a bunch. Right? I'm not even going to check right now for duplicates because I don't care. The Powerball ticket's going to check for me. Right? It might be nice to check now, but I already did that work. I don't have to do it twice. Right? That's fine. Right? And the simulator is going to complain about that right on our output when we try it anyway. All right, so there's the white numbers, and we need a red number. Red number. Print out, enter a red number, 1 to 26. Start parsing it at the keyboard dot next line. Great. And then my Powerball simulator dot play with chosen numbers given the white numbers and the red number here, and that probably gets printed out. Right? We can just print out all of that as well, because that's going to return a string. It's a little bit funky here, but probably gets the job done. Another parenthesis there. All right, should we try it? Oh, what is it not like here? Choice. Suspicious indent after a while statement. Oh, I'm missing my curly brace. Thank you, PyCharm. That saved me here. IntelliJ, sorry. PyCharm's for Python. It's their other product. As long as it's not a 3, keep on going. Pick out what their choice is here. If it's a 1, if it's a 2. Great. Think we're okay? Should we try it? Not the test here. Oh, goodness. I want the current file. There we go. Run my current file. All right, what do you want to do? Do you want to, oh goodness, that menu's ugly. Do new line, pick numbers? Okay, that might be a little bit prettier at least. Let's try that. All right, what do you want to do? Pick numbers, random numbers, or quit? Pick numbers. All right, white number. 15. 7. 3. 60. 1. And a red number. 20. All right, ticket. Oh, it does. Okay, so the rate list is a little bit ugly, but that's okay. It's showing me the numbers. We can make the output prettier if we care. There's no points for pretty output, right? So hopefully you didn't spend a lot of time on pretty output. Okay. Here was my ticket, the numbers we picked, the red number. There was their tickets. We won no dollars. We have lost $2. All right, what do you want to do?
Random number.
Okay, how many do you want to buy?
1,000.
1,000. It's going to be a little bit ugly, but that's all right. It's not the end of the world. We now have won $176. Yes! Except we spent 2,002 to win that much money. But some people might think they're ahead. Some people are stupid, by the way.
I used to have a coworker. We were salesmen. You know, show me his tickets. I will. Oh man, I won $200. But then making this, I'm like, you know.
How much money did you spend to win $200? Yeah. Yep. All right, let's pick a bad number just for fun, right? We do a bunch of duplicates. We get numbers can't be repeated, and nothing else changed. What do you want to do? So again, it's okay. We could do something better maybe with some sort of validation, but ticket should be responsible for that because ticket should not allow itself to be in a bad state. Okay. Now we did a bad thing here because we gave access to the array list. Okay, and we didn't make copies of the array list. So I do want to spend a little bit more time, or do you want to break first and then come back? Break? Okay, so I think we got everything we needed on the rubric, right? You can pick tickets, validates, random tickets, keep looping here, testing. I think this is done, complete. Now we'll come back and talk about a little bit more about array lists. We didn't get to it last week here after the break. Can we take 10? All right, awesome. We'll come back in 10 minutes. Let me pause this. All right, and I remember to resume. Awesome. So I did switch over to Coke. I did need the sugar. That's good, but I'll be extra awake for at least another hour or two, thankfully. So should be good. So I wanted to talk a little bit about array lists. We did a bad thing here that you might not have caught. So if you read the chapter, hopefully you noticed it here, and that's okay. But in our simulator, when we went and created a ticket here, we said, hey, here's a ticket, here's the winning ticket. Now, if I want to go and mess with the winning ticket here, I have access to it because we are returning our white numbers here. Now, we've marked it as final, so you can't change the instance of the array list here. Once you create an instance, that instance exists. But if I give you back that array list here, you have access to the methods. You can add or remove items from it, right? So if my get method here for get white numbers, where did that one go? Get white numbers just returns the white numbers here. You're giving them full access to that array list. Now they can't replace it with a new one in memory, but if they have this one in memory, they can go interact with it. So I can go take my winning ticket, get white numbers here, and we can call clear, get rid of all the numbers here, and then my winning ticket get white numbers add all, given my white numbers. Now I can't fix the red number, right? Because that one was private. When you return an integer, you're returning the value here. You're not passing the memory location, but an array list is an object. So when you return the value of it, the value of a pointer is where it points in memory, right? Think back to your C++ days with pointers, we hate them. But yeah, if I give you back the value, that's where this thing lives in memory. So I'm passing by value, but the value is its memory address. So I can go call all these functions on it here, and now all of a sudden I'm going to win a bunch of money here. So when I play my main here and pick a number, I do 1, 2, 3, 4, 5, and I don't know, 6 doesn't matter here. Look at that. 1, 2, 3, 4, 5. I just won $1 million. And we should format it nicely and all that good stuff here. But because I didn't give you a copy of my array list, I've done a bad thing. You now have access to it because an array list is an object. So we want to be careful when we return attributes that are also objects. If you want someone to have full access to it, great. That's perfectly fine. Most of the time you don't. So most of the time we want a copy of that one here. So what we would do then in our Powerball ticket class here, let me go back to Powerball ticket here. So I want white numbers dot clone. So clone is a, no, is that not, no, not a shallow, really? All right, hang on, I gotta Google it because I forgot. Java, create copy of array list. I thought it was clone, but it looks like it wasn't gonna work here. Make a separate copy of an array list here. You would need to implement clone array list, copy the clone, add all. I want a deep copy. So we know we're only storing so the shallow versus deep copy. Does this ring any bells from 200? Hopefully you talked about shallow copies and deep copies. A shallow copy is if this one is also referencing objects, you now have those objects' memory addresses, but at least you have a new container. So you have two containers, but both containers point to the same 10 things if we're using objects. So a deep copy makes copies of the copies, right? Or of the items inside of it here. So because we're dealing with integers, we don't have to worry about that. We can do the shallow copy, and that'll be okay. So we just need to do the casting here of our clone. So the clone is going to work, but we need it to. So by default, clone is written by the object class. We haven't talked too much about inheritance yet, but object exists. Everything inherits from object. So you get a couple cool things, and we're just going to go convert or cast this and say, hey, I really want it as the type of array list of integers here. Right? So make a clone. Clone says, oh, I only know how to clone objects. I don't know how to clone specific classes. We say, well, really, this is your class type here. Don't be silly, right? So this one I think should work. Let's give it a try now and see if we can fake our lottery or not now. So I think pretty sure clone works. So pick our numbers, 1, 2, 3, 4, 5, and 6. And even though we can still get the values, we can still call the clear function, we can call the add all function, but it's manipulating a new array list of values, not the original. Right? So this is very important here. if you don't want to have someone to have access here. And just a warning, this is a shallow copy, but it's only integers, so that's okay. That makes sense? Right, why that's fine? We didn't need to do the deep copy. Excuse me. Right. So this is good. So now you can't go and do this. Now these won't work. This won't work. Now that we set up clone, and you get flight numbers. Is that helpful? Set up? Is that really 2 words? Set up? I thought it was 1 word. It's 2 words.
I'm pretty sure there's one more.
Was it? Yeah, set up versus set up
Yeah.
is a noun. Okay, so that's the noun. Set up is the verb for. Okay, I'm terrible at English, so now we learned something here. All right, now that we set up, okay, because that's the verb here. Sure. All right. Anyway, so that was the one little warning here when you're dealing with objects, or because this was an array list here, it's an object. Be careful when you pass it by value, because its value is where it lives in memory, and you now have full access to manipulate it here. Even though we said, hey, it's final, you can't reassign it, you can't make a new array list, but array list lets you manipulate it, right? So this might be an advantage of just using an array, but then we wouldn't have had all those cool features like contains. We'd have to go do other stuff, right? So it was easy that this was an array list, but we have to just be a little cautious because you get other fun stuff with it, okay? Now, should we try and hit the jackpot? Should we try and buy like 2 billion tickets and see if we win? Pick some random numbers. Let's buy a billion, right? Or let's start with a million. We'll see how slow that is. So it's 1,000, 1, 2, 3 is a million. Ooh, it's taking a second. So this is where that string builder thing was really bad. Remember, it told us, hey, you're doing strings in a loop here. You should use string builder. That suggestion will make this a lot faster here. So check this out. So let's convert it here to string builder here. So a string builder doesn't need to make new strings in memory every time you concatenate a string. Remember, strings are immutable. So string plus a string means you just made a third string in memory. And I did a third string, a fourth string, a fifth string times a million times. We've just wasted a whole bunch of memory, right? So string builder doesn't have to do that every time. That's why it's much more efficient here. And that was the suggestion here is use string builder. So now we should be able to buy a million tickets and this will be a lot faster. So let's do random numbers. We get a million tickets. It's still not the fastest thing in the world, but you see we got results pretty quickly here. Um, so we won the $2 billion prize. Wow, look at that. We found a jackpot. All right. We actually won some money here. Buying a million tickets. Should we try it again? Buy some random numbers. We'll buy a million tickets. See if we get a jackpot again. Nope, we didn't get the jackpot now. I was kind of impressed. I didn't think that would happen. I thought that would take a little longer. We got a jackpot, amazingly. All right, so in this case, we're not losing money. I guess we got lucky, incredibly lucky. But questions, thoughts, concerns? Feeling okay? Right, cool. We'll put that one to bed. All right, let me go commit that here before I forget. We can move on to new stuff. Everyone's so excited for new stuff, right? File IO.
I got a question. You buy
Yeah.
it's how do you keep track on
One more time.
when you buy that many tickets, or let's say somebody buys a blind.
Oh, in real life, so you physically can't, and stores can't sell that many, like because it has to print a slip every time. Like, so the one lottery system that was mathematically breakable was Windfall. I think it was called Windfall out of the East Coast, and that one had a system that someone smart looked at. Was like, you can mathematically break this, and they had to like partner with the convenience store owner to be like, can we just sit here for 8 hours a day buying tickets? And he's like, are you going to pay me? Okay, sure. But yeah, otherwise you just can't buy a million random tickets here. I think you can order them online, right? Can't you play online? Right? How are all tickets you buy online? They probably put a limit there, right? I would imagine our Buy them online. Availability depends on your state. You can order tickets. Line FAQs. Let's see. How many lottery tickets can you buy? Legalclarity.org. That sounds like a legit site, right? Um, Practical limitations here. Online platforms have some sort of spending cap. Okay, that makes sense. So I don't think you can. That's an interesting question though. And you don't want to like the recent jackpot that was like some record breaking over 1 billion here got split because two people won it. So if you would have bought 100 million tickets to be like, hey, I'm guaranteed to win, you would have lost half the money to another winner because the prize gets split. So uh, moral of the story is don't play the lottery. Right? Don't waste your money. If you want to play the lottery, you now have a simulator that lets you play as much as you want. It is even more fun because you don't lose money. It's very exciting. All right. New stuff. File IO. Everyone's favorite. So let me go start up a new project. This is for File IO here. Reading and writing from files. These are local files, right? So that exist locally here. So there is a library we're going to use for this. We're going to import java.io. There's a whole bunch of stuff here. And if you don't want to have to type them all out, you can just say star, give me everything, right? Give me everything in the input output library. Now we've imported everything. It might be slightly slower. No one cares. And that's perfectly fine. And we can always go fix it later as we're going. But now I don't have all those red lines as we're making different things here. Okay. So to write to a file takes a couple steps, right? So anytime we're working with files, we do three things. You open the file for reading or writing, you read or write the file, and then you close the file. And those the operating system know you're done with it here. So we're going to do those three things every time. And then there's a whole bunch of stuff you have to do here. So I'm going to go and just sort of cheat here, and we'll go copy paste out here as we go. So this is we want to read. Use this one here. Goodness, I'll just steal his here. And it didn't copy, really? Is it not? You can't use Control C copy? I have to go through this way here? Oh, goodness. Okay. You use a buffered reader. The reason why we use a buffered reader is it does some cool file IO buffering to make life faster. Doing file input and output is magnitudes slower than any of the operations we've done before. It's still really fast on our computers, but it is much slower. So having this buffer class here does smart things, and we're thankful for doing smart things. So you technically don't need the buffer reader, but it's really helpful. And then we use a file reader to say, hey, I'm going to go read a file. You can buffer reader other things that aren't file readers. Don't worry too much about it here. And we'll just say test.txt. We can go read a file with the file reader. And yeah, we have to go catch this thing here. So when exceptions can happen, sometimes we have to catch them. And in this case, it might have a file not found exception. We want to go and catch this one here. So we're going to add a catch clause. For a file not found exception or some generic IO exception could happen here. I don't want to throw a new exception. I'm just going to print here. e.toString. And we'll do that for both of these here. All right, so we're going to try a buffer reader. We're going to try a file reader here. So we go and make a file. Now, where you look for files is relative to where the program is running. And we use relative file paths. You can use absolute file paths and say, hey, it's on my C drive in the folder called test here. That's not very portable. So most of the time we like relative files, right, because absolute file paths get to be messy. Now you can put absolute file paths in some sort of configuration, lots of options there, but for now, relative files are just quick and easy here. We'll just go and try and read a file out here. So I'm going to go add a new file. We'll call test.txt. And hi there, happy Thursday, the end. Okay. And I'm going to go try and read this file reader with my input here. I don't know, input, whatever you want to call it here, file reader, buffer, whatever, it doesn't matter too much here. Why is it complaining? We did that, didn't we? Oh, too many curly braces now. Sorry. How did that happen? Right. So now we're going to try and read it here. So now that I have the input here, I can go and do a couple things. Okay. I can read one line with read line, right? Or I can get the stream of lines. This one's not as useful here. So most of the time we just want to read the line here. I want to read one line at a time. And we want to keep on going as long as we have more lines to read here. So we can keep on looping through here. Again, I'm just going to bar off of this here. We're going to read the line, and as long as it's not null is the idea here. So check it. If we got to the end of the file, it's going to give me back null. So we're going to go read the line. So we'll have a string for the line is input.readLine string, there we go, line. And while my line does not equal null, right, null's that special, nothing doesn't exist, not here, we can go do something with it. So we can print out the line, and then we want to go read the next line here, right? This just reads it one line at a time. This is really boring. We're just going to open it for reading here. Put it in the try block, and then when we're done here, the right way to go about closing this is with a finally block here. I'll take my input and we'll close it, right? Input dot. Is it not letting me? Shoot. Oh, because I put it in here. It's going to close it for me automatically. We can even skip that. If we didn't put it inside the try here, we'd have to close it automatically. But we're doing some fancy stuff with the try set of parentheses. So usually we would go and close it here. We can say input dot close, and you would do this in the finally block in case something happened. And right now it's telling us, oh hey, it's happening automatically. It's redundant at this point because we put it inside this try here, which is nice. All right, so not very exciting, but it should go read that file here. And if it doesn't find the file test.txt, it should yell at us. Right, but we get, here's the line, here's the line, here's the line, here's the line. Now, what's interesting is it reads the line, but it doesn't give me the new line character from the line, right? Because when I print line, I get the new line character. So it's reading everything up to, but not including the new line character, which most of the time is good. Most of the time we don't want that there. So we can go read out our lines. Right? So we can open up a text file, read from it. Now, if we wanted to write to a file here, so let's go ask him here. We'll say, do you want to read or write file? And we get a string for choice, keyboard next line. Oops, I didn't make that here. Scanner keyboard equals new scanner, given system in. Right, and yeah, import that one. There we go. Right, so we got the choice, and if my choice is equals, probably ignoring case here, right? Read. We can go do this thing here, and we could even ask them like, what's the name of the file, right? Because it doesn't have to be test.txt here. So we get a string for a file name, right? So go ask them, enter the name of the file, and this will be the keyboard.next line. So give me that capital L here, and I can use that file name here instead of it being hard-coded. It's not with a quote though. And we'll read whatever file they told me, or it will crash because the file doesn't exist, right? And again, making it crash is kind of ugly here. So it'd be better to come back. So we'll come back to that here. So these don't crash on file not existing. We'll come back and look at a better way to do that in a minute here. So then if we didn't want to read, if we wanted to write, then else if my choice is equal ignoring case write, we probably want the name of a file, right? The name of a file, get the file here, and you guessed it, we're going to use a buffered writer. You guys are so smart. Look at that. You're picking up on this already with a file writer and a file name. So we'll go catch some stuff here. Create a buffered writer for output. I don't know, why not? Output is a buffered writer given a file writer, given the file name. Now we're not going to read anything out of it here. We're going to say, okay, what do you want to put in here? Right? So now we need a string for, I don't know, content. Starts off as nothing, and while my content does not equal ignoring case, right? Doesn't equal quit or something. I don't know. We'll ask them to enter some content here, right? So we can say, hey, enter some content or quit to stop. and content. Oh, there we go. Then we can set it as the next line here. Keyboard.next line. And then we just keep on repeating here inside the while loop with resetting content. And we're going to write. So we're going to take my output here. We're going to write here. What do we want to write? We want to write the string of content. Right? So write the content. We keep getting content. Eventually they hit quit and we're done. Do we not need catch branch? We can collapse the catch blocks. Look at that. You don't need the specific type here. That's nice. Sure. So we can read or we can write. And we'll do that just once here, right? We could put them in a loop to make them do it over and over and over again, but this should be fine. So if you want to write a file here, what should we call our file?
Hello.
Hello.txt. What should we put in our file?
Hello.
Hello world. Yeah, hello world. Ha ha ha. Quit. All right, we'll quit out. Now there's a file named hello.txt. We didn't add any new lines. We wrote the strings. We didn't capture the new lines. So we got to go and add our own new lines, which is kind of obnoxious, but that's okay. So we write the content plus a new line. Sure, we can do that, or maybe we go write again a new line. I don't know how we want to do it here. I'll put write given a new line. Sure. Either way should be fine. Let's try it again. Let's go write a file. Should we write hello.txt? Hello world. Some content here. Quit. Now hello.txt has new content. Now, a warning here, and you might have noticed now the file got erased. Right? So when you output here, you got to be careful. This will erase your file that already exists. Right? When you call writer, it blows it up. So if it was there before, it's gone. There is a way to start appending to files here. That one, the file writer, I think we give it, is it an argument here? No, file writer in here. I can go Google it here. Java file writer, append mode. Go Google it here. The file writer. I thought I did that with file writer. File writer, file name, comma, group. All right, it was red, but it works anyway. Okay, I had to Google it, so that's fine. We'll go with my Google search. Oh wait, we actually had a Stack Overflow link we can cite here, right? We can be very specific. Oops, we should put that in the right spot though, right? File writer, true, above it, right? So in append mode, it doesn't erase the contents, right? Kind of does what's advertised, right? You're familiar with appending, right? Name of the file, hello.txt, more content, goodbye, quit. Now hello.txt has more content, and life is pretty good, right? So if you want to append to your file, you have to put it in append mode. You could even ask the user, hey, the file exists. And we haven't done that yet. We'll do that in a second here. Do you want to open it for appending, or do you want to erase the contents? Right? Why not? We should ask them here, right? Without append mode. Let's go do that. So to check to see if a file exists, we can make a file equal to new file, given the file name. And you can say, hey, if my file.exists here. So if the file exists, we can ask them, do you want to overwrite or append? Right? We got that option here. So if my file exists, we need a string for overwrite equals yes, maybe, or y for now here. So if the file exists, we can ask them, do you want to overwrite the file? And ask for a yes or no or something like that here, sure. And then we can get the new value for overwrite keyboard.next line. You should probably validate it here, make sure we got good input, but we're feeling lazy right now. That's okay. At some point here. So now we have overwrite here. It's a yes or no. And then when I go do this one here, I'm either going to append true or not true. Right? So I'm going to append this overwrite equals, I'm sorry, not equals ignore case, a Y. Because if they said yes, right, or if the file didn't exist, I never asked them, it'll be true. Oh, we want not that. Shoot. Because no, wait. Overwrite was yes. I'm sorry. Overwrite. So yes to overwrite means not true because we put a true if we wanted to append. I'm confusing myself here. Sorry. So append here. Let's see that as append. Append then. We'll say no to start. And do you want to append the file here? And I can say, okay, append equals y. So if they entered a y, yes, it will be appendable. Anything other than that, it overwrites the file. Right? And we're going to default to not appending here because the file might not even exist anyway. Right? So we don't even have to check. Does that? I think that probably follows. So let's give it a try. So I'll ask him. So we want to write a file, hello.txt. Do you want to append to the file? Yes, let's append to the file. Append mode, yay. And quit. And now hello.txt. It worked. Cool. Feeling pretty good. Let's try not appending to the file here. So we'll write a file, hello.txt. No, we don't want to append to the file. New content only. Yay, and quit. And hello.txt has just the new content. So it seems to be doing what we expect here, which is nice. So we can check to see if the file exists first, and then do something based on that, right, which is really nice. So this is all text-based files here, right? Not the most interesting thing in the world here, but text-based files are fine. And you do a lot of things with text-based files here. It's okay to put text in. What gets harder is like saving the state of something in a text-based file because there's a lot of details and we have to read out all the details. We have to know the details. So if you want a program that can save its state, you need to either decide on how you're going to read the file first or decide on how you're going to write the file first. If you know one of these things, you can reverse and get to the other one, right? But you have to be able to read it all out in a format you want to read, or you have to be able to write it all out in a format you want to write, and then make the other one match, right? So if we wanted to have a program that saves its state, we can go do that. I think Powerball Simulator is pretty boring, right? It would just have the total spent and total won. So we could read that to a file, write it to a file if we wanted here. Um, that one's a little bit boring here. Uh, let's do a different one here. Should we write a different thing? I'm sorry?
Can we do CIS files?
Yeah. I think there's a built-in one here. CSV meter. I think there's one here. Yeah, there's a library, open CSV. Oh, so it's not built into um, the Java library. Python's much more easier to use that way. So there are libraries people wrote for it, but there's not one built in. So you just have to go use someone else's code for CSVs. Um, you can do your own, but doing this is always awful. Trying to split on different lines and things because there could be commas inside of quotes, and you want to be careful that depending on how it was delimited, usually you have quotes around ones that are comma, but then you don't always have quotes, and it's just a giant mess. CSV files are obnoxious. Um, so you could, but yeah, it's a little bit trickier here. Right, so we want to go and write something to a file, like save some sort of state here. So how about we have like a shopping cart? That's a nice, easy one here, right? So if you want to write a class for shopping cart, here, shopping cart, shopping cart. And the shopping cart then probably has what? It's like a list of items, right? That's really all the cart is. So we're going to make an array list type item or items. And that's really all it does here. It's not very interesting. So now let's go write an item class. Class for item here. And then item has what, like a string for name, an int for quantity, and a double for price or something like that. Sure, just something pretty boring here. Let's go and add some functions here. We can generate our constructor, have all those things here. Great, add a getter here. So generate the getters for all of them. If you want to set, maybe set's fine here. No, not too concerned about it. Should be okay. Um, maybe we can add some sets here. Why not? So we can add a no argument constructor in the sets. Those make this life a little easier. We'll generate a constructor that takes no arguments, and then we'll generate some set methods here. And now this one should give some defaults, right? So name equals empty string, right? You want to give some default values here. Quantity is 0 and price is 0 here. And then we can add the set functions or set methods here too. So we'll generate our sets for all of them. All right, so we get set. Life is good here. Shopping cart is a list of items, right? So we got to import array list. Cool. We need a constructor. So we'll generate a constructor that goes and gets my list of items. Now, probably to start as a no argument constructor. Sorry, so just items equals a new array list here. And then things you can do, you could add an item. So public void add item, takes an item, takes our items.add the item. You could probably remove an item, right? Probably something you could do with a shopping cart. Remove item, item, takes my items.remove the item. Okay, so we can set or add item, remove item. Now, probably want a way to get that list here. Again, this is where clone becomes bad. If it's a array list of other objects, we have a shallow copy. So we need a way to make a deep copy. So all of these things need to be able to clone themselves here. Which is not the end of the world, but we have to go and implement a couple things down. So public array list of item, get items here, and return. So we want to make a loop through all of these ones here. So we'll make an array list of item copy. So new array list of item, and then for item in my items here. We're going to take the copy, we're going to add item.clone. Oops, item dot. No, where's my clone? Oh, I didn't write one. Sorry, we have to go add a clone. Um, I guess we can just use it. We'll just use the constructor right now. We'll make a new item given item dot name, get name, item dot get quantity, and item dot get price here for list of items in items. What? Derestions items produce null pointer exception. It's not void. What? I don't know what that suggestion is doing for me right now, but that's okay. And eventually we can return the copy here. So we just made a copy ourselves. No, return outside. Feel like it's confused right now. Oh, I don't have parentheses. Oh my goodness. So what I get for trying to write my own methods and not letting it generate the code for me with missing some parentheses. Now it looks a little happier, right? All right, so we got return the copy. So we just made a new instance of item. We made our own deep copy here, right? So this is a manual deep copy. Manual deep copy. Just to make sure they're not doing weird things to us here. And we got item. There's no related problems now. Life is good. We got gets and sets here. All right, so we need to go and we can either load a shopping cart from file or make a new shopping cart, right? For our menu here. So we can say, let's use our keyboard here. So we can ask them here. So we'll have a string for load. I guess we can output first. You want to load a shopping cart. Shopping cart. And Y or no. Here, keyboard.xline. It's fine. And if my load equals ignoring case is yes, here, we need then to go and load a shopping cart. So we have to go read the file. I need to know what the file is, right? So if you want to read a bunch of items out of a file and put them back into a shopping cart, what format do we want to use? Well, one strategy, and the way the book does it, I think is fine here. They have essentially a toString, but it's for files, and they add in a delimiter. So I can say I'm going to write a single line. I'm going to put the item name and a character. I'm going to put the item quantity and a character, and the item price. So I'm separating them like a comma separated values file. We can add in commas here if you wanted. Now, you want to use a weird looking delimiter here because you don't want it to be something else. The other option is we could write one line for name, one line for price, one line for quantity, and just do it one at a time. that's okay too. So maybe we'll start with that one first because the book has the delimited one here. So we'll go through and we want to open up that file. So we're going to go use our file reader. Where did that one go here for reading? Given the file name here, we'll go do a bunch of things here. So I need the file name and nope, not that one here. Nope, that's all supposed to be inside of this one here, right? If try, okay, and then our catch. So I didn't copy enough of this, did I? Catch my file IO exception here. Okay, we got to give the file name. Let's give the name of the file. So what shopping cart are we going to load here? We can try and open it. Now, what I want to do is I want to read three things out. If I know I have 3 lines per item, the first line should be name, the next line should be quantity, the next line should be price. So this loop gets to be a little bit weird here, right? So I'm going to have a string for, really this one will be item name. So this is my item name, is that one. And then I'm going to have a int for quantity is my integer.parseInt of the input.readLine. And I'm going to have a double for price. Goodness. Well, price given an integer or double.parseDouble of the input.readLine. Then I can make a new item here, right? So if I'm reading out my file, I need to make the shopping cart. So I'll have a shopping cart equals a new shopping cart, right? And I can take my cart and I can add the item of a new item given the item name, quantity, and price, right? Add that to my shopping cart. Then I'll go read the next item name, right? So item name is the read line. Oops, too much. If that's not null, I know I have more to read because I'm going to write one line, one line, one line for every item. So I know I can essentially read them 3 at a time here. I'm not reading one line at a time. If we use the delimited route, every item would be on one line. That's okay, we could go that route too. But this should give us the shopping cart here, loaded, all ready to go. Actually, let's put the cart above, right? Because I might make a new one otherwise here. So cart is a new cart this way here. I guess both ways it's a new cart, isn't it? Whether or not we load it or not. So if we don't want to load, here it's just empty. That's perfectly fine. If we did want to load, we'll go and read that out here. Okay. Um, so that's my loading shopping cart. And then we can say, do you want to add items here until you're done? So I'll have a string for add items. We'll start off as, we'll probably be y. Yeah, we want to add some items here. And while my add items is equal ignoring case to a y, let's go add some items. So we'll print out, enter the name of an item to add, or quit or something, or I don't know, just the name, sure, right, to add to your cart. And then we get a string for the name, keyboard next line, and print out, enter the quantity, we have an in for quantity, is my integer.parseInt of the keyboard.next line, next line, right? And then we have enter the price, and we have a double for price is double.parseDouble, double parse double keyboard.next line. Okay, and then we can take my cart and I can add an item given the name, the quantity, and the price. And we'll ask, do you have more? Right, so add items, then so you have more items to add, a Y or an N here, and go and set that one, add items is keyboard.next line, and if they gave me a Y, we go back and add more items, right? What is this? New item, sorry, new item, call that item constructor, there we go. Okay, so we can go and add an item, maybe they add more, maybe they add more. Once they're done adding items, we want to go write that file here. So to write our file, once we're done, we'll go and open up a file writer. We'll just do it the cheesy way right now. We'll just open it every time. Buffered writer, file writer. Oh, that's gonna be ugly to copy. That's fine. We'll do the try and the catch block. All right, so we're done with the cart here. We don't want to append. We're going to assume no appending right now. That's probably fine. 2, 3. So we need to know what file we should save this to, or maybe we just save it to shopping cart, right? We're going to do that for a shopping cart.txt. Sure, we'll just save it to shopping cart. Now I'm not going to prompt them for anything here, right? All I want to do then is for every item. So for item in my shopping cart.get items here, I'm going to take my output. Oh, I don't need this line here now, right? I'm going to do the comment output dot write line, and we're going to write the item dot get name, right? And the new line character plus the new line character, right? And then we're going to write the item get price or get quantity, and then the item get price and the new line character. Right, so we're going to write all those things here for every item in the cart, and then we're done. Okay, so it should get us through for shopping cart. Let's try it. So there's nothing right now. We don't need to load anything because we don't have a cart here. So what should we add to our shopping cart? A car? Sure. How many of those are we going to buy?
7.
7 car. All right. And how much does it cost?
A million bucks.
A million. 3, 1, 2, 3. All right. Cool. Do we have more items to add? Yeah, let's add another item. What else are we going to buy?
Laptop.
Laptop. Okay. How many?
1,000.
1,000 laptop. All right. And what's the price?
$2.
$2. All right. Easy. Any more items?
Yeah.
All right. What's next?
Your basketball.
Basketball. How many?
Just one.
All right. And how much does that cost?
3.
$3 million. That must be signed by somebody famous, right?
Michael Wood.
All right, cool. We'll say no, we're done adding our items. And then it should have made our shopping cart file here. Let's see, it's not show. Oh, there, hasn't shown us yet. Refresh. I think I just need to stop my program. There it is. It didn't IntelliJ didn't show up here, but now we have shopping cart. Car, 7, a million. Laptop, 1,000, 2. Basketball, $1, 3 million. Now it has this last trailing new line, right? Because we went down a line, but there's nothing on it. So let's see if loading works for us here, right? So I can actually put this in debug mode. Right? Debug mode's your best friend. And we want to watch this work as we go. So if we wanted to load here, let's try to read some items out here. Probably maybe about here, we'll pause. So yes, we want to load a shopping cart. Shopping cart.txt. Right, ready to go. It got the name car. Cool. And we're going to read line. You got the quantity of 7. It got the price of a million. Great. Adds an item. Item name is next one here. Laptop, 1,000. Price is 2. Good to go. Basketball, 1. A million or 3 million. Good to go. Item name now is null. So that last line there still comes back as null because it wasn't actually, there wasn't anything there. It was just the new line took us down that line. So the reading worked okay, right? So now our shopping cart has our items here. And we can see in our shopping cart here, here's all my items, right? We didn't add a toString, so they look ugly. If we wanted to add a toString, right, they would show up really nicely here, but we can see them if we go and expand all their attributes here, which is nice. So life is good. We should be able to add more items. And overwriting the file is fine because we loaded it, right? So we're always going to overwrite shopping cart. Eventually, we might want to ask them, hey, let's save it to a different location or do something different here, but that's okay. So we're getting through here as we go. With our text-based reading and writing. Okay so far? All right. We got one last concept to look at, and then we'll talk about the project. Should we take one more break before we power through? We got till 8:45. You want to take a break now or just go? All right, I got to vote for break. You want 5 minutes, 10 minutes? 10? All right, take 10. All right. And then we'll come back about 8:15 when we got half an hour left. We'll talk about the next thing we can do with file reading and writing, some of the shortcuts we can do, and then the next project. All right? Cool. See you in 10. Cool. So I did remember to resume. Oh, I gotta show the screen again here. Sorry. I had to go jog my memory here. I did this a while ago, and I couldn't remember. So I had to go look it up again real quick. So the other way we can write data in a file is not text-based. It's binary. So the actual data itself is reading and writing bits. Actually much more efficient the formatting gets to be a lot more awkward for it here. So I'm just going to copy a bunch of this here real quick. Let's go to try and a catch here, and I'll show you what that looks like here. So let's go throw that maybe at the top of our shopping cart here. So we're going to use a data output stream is our binary type. So instead of it being a file output stream, where did we go for that? For buffer rater and file rater, we use the data output stream given a buffered output stream given a file output stream. And I'm just going to call it bin for binary. Sure, I don't know. Someone came up with it somewhere. The extension doesn't actually matter, right? But if it's called .txt, Windows will try and open it as a text file, and it won't be able to do that. Okay, so we're just going to write a bunch of doubles here to this file here, um, and we'll see what that looks like. Let's go and run it real quick, and now we should have. We'll stop. Oh, did it crash on me here? Oh, there we go. Okay, and then we'll just stop. I don't actually want the rest of it happening here. I'm in numbers.bin file. When I try and open it, if we just open as a text file here, it looks like garbage. Oh, hey, do you want to install bined, a binary hex editor plugin? That's probably fine. I don't know. I haven't tried that one before. What I've done before is I used VS Code, and I'll just do that one because I'm familiar with that one here. So I'm going to open up VS Code here. This is a nice flexible editor. You can do a bunch of cool stuff with it here. Uh, and I'm going to go and open that file. So I'm going to go find where that one is here. So that was in my GitHub, 296. Goodness, I can't look at numbers right now. 290. Is that not 296? GitHub. It's the wrong one here. I have two documents folders because OneDrive is fun like that. 290. There it goes. I was just scrolling right past it here. File IO. Here's the numbers.bin file. Again, it looks like garbage. It says, hey, it's a editor can't open it here. We're going to open anyway. And we want to use the hex editor. The hex editor will open this up and show me the hexadecimal representation of this file. It's crazy, right? But I can see here's the individual bits that were set here, which is crazy looking, right? The decoded text is garbage. It's because it's not text here. But we can see individual values here. So the first thing I wrote to this file was 420.69 here. And in here, so the first, so that's 1 byte, 2 bytes, 3 bytes, 4 bytes, 5 bytes, 6 bytes, 7 bytes, 8 bytes here, right? In those 8 bytes here, we've written that data. And not super easy to see because it looks, like garbage here. The next value, let's see, what do we write after that? Was 137. I think that one will be a little easier to see here for 137, the next set of bytes here. So that one, we see, it shows our values. I think integers are probably easier. I shouldn't have done doubles. Sorry, doubles are silly. Let's go back and write integers. Let's write int here, and let's write, I don't know, 5. We'll fix this here. It'll be a little bit easier. Sorry, 5, 8, 12, and 500 or something. Sure. Let's go run that again real quick. All right, and then come on and stop. All right, and reopen numbers bin. Okay, now it looks a little bit different here. There we go. So now in the first 4 bytes here, because an integer is 4 bytes, we see the value 5. And take assembly, you can learn how we actually store this stuff in hexadecimal notation. It's silly. There's 8. 0C is the 12. And then the next one here, 500, was this byte and this byte all together here, right? So all combined, the 4 of those, right, was 500. So you can look at the binary representation here with the binary file, which is really fun. And the amount of space this is using here to store 4 integers here, right, is 4 bytes times 4, 16 bytes of space here. So the file here is actually ridiculously tiny if I go and look at it here in Explorer, which is really fun. So the file itself is less than a kilobyte. Right? To put a bunch of numbers in here. If I were to put those in text, remember each character takes up, oh my goodness, how many bytes is it for a Unicode character? Size of a character in Unicode. I think it's 2 bytes, right? UTF-8 is 4 bytes. Sure, probably 4 bytes here per character, right? And that's for every character in the number versus just 4 bytes for the integer. So you can do some fun stuff, and it will be more efficient to store it in a binary format. The problem is to read things out of a binary format, you have to read it byte by byte by byte or value by value by value. You can't just say, hey, I want a line and do something with it. So it takes a little bit more practice to get those things back out. And to get them in, it's a um, try block. We'll go read our file in here and binary input file. We just want to use the same numbers bin here. We don't care what that one was. Numbers bin, and I'm going to read integer. So you can read specific values out with your binary input. You have read doubles, bytes, chars, floats, longs, right? A UTF string. So you can write strings here, and it can do it one at a time. But it gets to be a little bit tricky. So we're just going to read int because I know they're ints here. We'll go sum them all up here. We can get the values out of the file, which is kind of fun. So storing things in binary format, much more efficient. So 525, right, should be the sum of this one, 525. I think that's right. So we were able to write it and read it back out in binary form. It was really nice. But that's still a pain, right? Having to do it byte by byte by byte by byte. So the other cool thing we can do is we can take this shortcut, and Java knows how to serialize things for us, which is a fancy term for give me some sort of stream that I can use here. So in our item class, again, we haven't got to interfaces yet. We're going to say implements serializable here from the Java IO library. There's a couple things you have to do to implement serializable here. Java implement serializable. There's a few things we need here. Where's the list here? Is this one serializable? I don't know. Implementing it. Where's my list here? You have to make them here so you can be serializable. So you're at, I had a list, I don't have it. The book doesn't have this one either, which is sad, but this is super cool. So we just mark it as serializable, and if all of our attributes are serializable, life is good. If one of our attributes is an instance of a class, that class also needs to be serializable. So it has to be serializable like all the way down the chain. So that's why I'm doing item first. We'll come to shopping cart, we'll say implements serializable here. Then I can just go and write this as an object, which is really cool. So instead of all this other stuff we were doing here before with writing all out this way, we're going to write it as a single serialized object real quick. My goodness, I have to Google that one again here. Java write serializable class. You want, oh, that's the interface. Goodness. I guess just this being examples will be fine. Here's my class. Yeah, an object output stream. There we go. So this object output stream here. So being AI, oh yay, we got AI generated code. So with my shopping cart, no, why? I just want the code. That's all I want to copy. Let's click the copy button. Nope. Why? Really? Okay, sure. Object output stream. That's all we wanted. Why did it give me the rest of it here? Okay, that's fine. So we're going to write it here with an object output stream. We're going to write our cart here. We're going to call this one cart. Use .ser for serialized. Sure, why not? Here, that's fine. Object has been serialized. Sounds so fancy here. Let's give that a try and see if we can write our shopping cart as a serialized object here. So yes, let's load the shopping cart. That is shopping cart.txt. Load it here, and let's add one more item here. Probably coffee because we're all tired here. Definitely need 2 of those for 250. No more items to add. Object's been serialized. And let's just go ahead and stop it here. So now we have a cart.ser here. Let's look at it as a text file. It looks like garbage. Right? It's a binary file. So I can't go and read this as text. Now there is some stuff here, and it's like, oh, hey, you have an array list, you have an array list. It's got some stuff in here. Hey, here's a quantity. Here's like some of it is text in here, but it's not human readable, right? But now I can go and just read this back here. So I can use the, oh, I was highlighting too many lines here. That's my problem. Deserialize here. We can go read it back. My goodness. All right, it was right here, step 4. Just copy it back from here. This is going so well. So I want my object input stream is my cart.ser, and I want a cart is the deserialized cart. And we have to cast this thing as a shopping cart from the read object. So object input streams only know what objects are. We're going to say, go read it. By the way, this is the type that you are here. Let's say shopping cart, sorry. And then we've deserialized it here. Again, I'm just going to put a breakpoint in so we can go inspect it real quick here. We don't need to print any of those details out here. Um, and then possible exceptions might happen. So let's go write the file, read the file real quick, and we should have all the details here. So load a shopping cart, yes. We want shopping cart.txt. Great. And let's add apples for $1 and 2 of them. No more items to add. Serialized, deserialized. Forgot to run it with the debug button. Didn't click debug. Shoot. All right. One more time. Run it with the debug, not the regular run mode here. Load a shopping cart. Shopping cart.txt. Oh, we don't need that one here, so we're going to take out the breakpoint and continue. Go back to our console, enter the name here. I don't know, bananas, 2, sure. No more items to add. We deserialized, we deserialized, and now we should have a shopping cart called the deserialized cart here. Our deserialized cart is a shopping cart. It has 6 items in an array list here. All those items in the array list are of type item, which is awesome. So it got my attributes back here real quick. So other fun things we can do, right? If we go change shopping cart and go say, I want other attributes here, as long as they're primitive types or it's a class that is serializable, we can just keep on adding more things to it here. So maybe this one has, I don't know, like the store name. You can have a shopping cart for Meijer. You can have a shopping cart for Target. You can have a shopping cart for Walmart. I don't know, whatever we wanted to do here. We can have a string for store name here. Uh, I don't know. I wanted to show more attributes here. I guess that was a little bit silly. We'll say store name equals test. I just want to show that that one comes through. So let's go run it one more time, and we'll write it and read it. Load a shopping cart. No is fine. Test 1, no more items. Didn't run it in debug mode again. Oh my goodness. You guys, no loading. Test 1, no more items to add. Here's our deserialized cart, and it comes back with the name, which is super cool. So you can have all sorts of attributes saved. So this makes saving objects really easy. Again, it's the binary format, but we don't have to say, okay, read these 3 bytes, read these 3 bytes, read this one as a double, read this one as an int, because it's done for us. We just serialize it, and life is good. So really nice and handy there for serializing stuff. Okay, should we talk about the next project then? All right. Let me go make a new classroom link here. These are, I think it's gotten a little bit better. It was, I think, only flaky for one person, so I think they were just having some trouble the first time we tried it. Fall 2025, project 2. We'll use the Java template. Library repositories. None of that other fun stuff here. Make our assignment. All right. New project. Project 2, due in 2 weeks here by the start of class for, how many points did I make that last time? I forget. Is this probably like 20 points? I forget how many points the other one was. We can change that if we need to. The other one was 20? Oh, that's probably worth more then. Let's make this one worth 25? Let's say 25. Please submit the URL of your repository. Add a screenshot of it running and a self-assessment to the README. Okay, assessment. There we go. All right. So we are going to go and build out a little game, and we're going to save our state here. So we're going to create a basic version of Monopoly. Okay. So we're going to have properties around the board, right? So we need a property class. We're going to have a class for property. Property has its name, rent price, and owner. So if it's not owned, right, blank or however you want to handle that, it has no owner, it's available for purchase. If it has an owner, if you land on that property, you have to pay that person rent. Have you guys played Monopoly before? You getting one yes? Anybody not played Monopoly? Okay. This is going to be interesting then. It's going to sound like a bunch of weird rules, but it's all right. So that's our class for property. So we don't, we're going to skip the chance and community chest. So it's a couple of the extra rules and fancy things the game has we're just going to skip. So we'll have the properties. It might just be like a nothing then. We don't need to do any of the fancy ones here. Have a class for player. Um, has the name, money, and list of properties owned. Properties they own. Right. So as you purchase the property, your player should know about it here. Um, so the owner, um, maybe we'll just say owned, and if it's owned or not, might be easier because then your player can have that property. I guess then you'd have to see who owns. I don't know. There's we'll just say owner. That's fine. There's a couple ways you can go about tracking that. So if you have the list of properties, you'll see which player you landed on, so you know who you have to pay money to. Um, Maybe we don't have to keep the list then, because that tracks it. That's fine. So name and money. We have a class for the board. The board, which has the list of properties, and knows where all the players are on the board. Right. So we'll probably have like a list of players. So something about it might have their location, maybe location on the board. Right? However you want to track that. You could put these in different places depending on how you want to go about it here, right? So we'll have some places to put these things as we go, right? And then we're able to, when it's the player's turn, if they have money, right? So if you're down to 0 money, you're out, you lost here. You can roll 2 sided dice, and move that many spaces along the board. If you roll doubles, you can roll again. If you roll doubles 3 times in a row, you go to jail. Do not pass go. Right? Per jail, just charge them $50 and get them out. Like usually you have to roll and you spend a turn in jail, and that's probably more complicated than we need to do here. So just you go to jail, you pay $50. That's it here. Um, every time you pass go, then you lose the game. Yep. So just take it away. They're negative, and now they're out of the game essentially. Every time you pass go, you get $200. Um, if a player runs out of money, um, you usually would give all the property to the person you ran out of money to. That gets a little bit awkward here, so we'll just put all their property back to unassigned. I'll put their property back to unowned here, so that way it's available for purchase here. Name, rent price, purchase price, the owner, so you need to know how much it costs to purchase the property here. Um, Player start, and then we need to be able to save and load our game. Add a save and load your game. I strongly recommend you use the serializable class or interface here for that. It'll make your life a whole lot easier because you can just serialize everything and write it, and then you can just read it. You're back up and running. Not everyone might have actually listened to all of this here, so we'll see what kind of interesting ways people come up with. That should be fine. All right, and let me go. No, not an external tool, just to you. What you? Oh, all right, and then we got a rubric. So we're going to add, this is for project 2 for grading. We've got, I don't know, classes for gameplay. We'll say 10 points for having classes here. You've got a class for property, you got a class for player, class for the board, whatever we're doing here. Points for having some classes here. And then the gameplay itself, players move around the board, buying property, paying rent, pass and go, going to jail and stuff here, right? All those things happen, right? We'll do 10 points for that one here. And then we'll do um, game save and load. Let's do 10 more points. We'll make this a 30-point project. That sounds fun. We'll change that then. 30 points if possible. Okay. Each project, we were using all the things from before. Just like a math class, you don't get to forget anything here. Um, so ideally, saving and loading is not the hard part of this because we can use the serializable interface. And we'll just say, hey, I want to be able to serialize if we write our classes in a way that everything is stored in the class. Right? If you have a class for the Monopoly game and it has the list of properties and the list of players and it has the board and it has everything there in a single class and it has methods for like current player's turn or knows who the current player is, you interact with that class through its public methods, you can save it. Right? If it's a big jumble nonsense in your main function, it would work, but saving it's going to be a nightmare, right? Because then you have to go through and loop through all the different things that you have here and do it all separately. So lots of different ways to go about it here. Um, Again, we'll be able to do this one in 2 weeks. This one usually takes me about an hour and a half. I might not even do all the features here just to save some time and just implement a few of the basic things when I show a solution because I don't want to take up the whole night in 2 weeks. But that sound good? All right. Um, Again, basic version. Don't stress too much about any of these things here. But play again when you get doubles is important. There's some additional logic that goes in here, but shouldn't be super crazy. There's just some things to think through of how we're tracking who knows what property it is, how do we compare what player we're paying money to, right? When you pay rent, you give your money to that player. So that player increases their money because they own the property, your money decreases, right? When you get to $0, you're out here. Did I put that in here? Yeah, if you have money, yeah, they go back, all the property goes back to unowned. So the player's turn, if you have money. So you can leave them there with $0, right? They're just they're out because removing from them from the array list of players is doable, but that takes other things we haven't done yet. It can cause a little bit of a headache. So it should be pretty good. Questions, thoughts, concerns? Great. Again, about 9 hours a week worth of effort for this course. It's a 3 credit class. Here, if it's taking you more than that, let's have that conversation. I want to chat and see what's up, how I can help. But you know, 9 hours a week is about what we expect here. So it is some amount of effort here. Just keep that in your back pocket here as we go. So we're about at the end of this week, 36 hours in here towards learning Java. So, all right, cool. Let me stop recording. I'll post that on YouTube for you.